Hello class, welcome to our online lecture in statistics and probabilities. So here we're going to have our continuation of our discussion on estimation of parameters. So in our last video, we learned some of the basic concepts relating to estimation of parameters. We differentiate parameters versus statistics. We also learned what is statistical inference and the difference between estimation of parameters and hypothesis testing. And we also have a brief introduction on what is estimation of parameters. We also learned that there are two categories of estimation. So we have point estimation and interval estimation, wherein point estimation is defined as using a single value that estimates the population parameter, wherein interval estimation on the other hand is defined as using a range of values within which the true value of parameter is believed to be found. So in this video, we are going to learn how to perform point estimate of parameters. So again, to define point estimate, it is using a single value. So these are single points that estimate parameters directly, which serves as the best guess or best estimate of unknown population parameters. So for example, we can have the value of the sample mean to estimate our population mean. We also have the value of our sample variance to estimate the population variance, or we can also solve for the value of the sample standard deviation in order to estimate the population standard deviation. So these are single value that estimates the population parameter. So here are some of the point estimators. So again, for the sample mean, here is our estimator, which is the formula for sample mean. So sample mean is our estimate, and this formula is the estimator of sample mean, or the formula of our sample mean. So we use this formula in order to estimate the value of our population mean. So wherein x bar is our sample mean, x is our individual observation, and n is the sample size, the size of the sample. So let us have an example. So suppose that we would like to solve for the mean of the following. So we have 1, 2, 3, 4, and then 5. So let's say that these 5 observations are coming from a population. So this is our sample with size 5 because we have 1, 2, 3, 4, 5 observations. So to solve for the sample mean, we use the equation x bar is equal to the summation of our individual observation divided by the number of our sample, of the number of our sample. So we can use here small letter n in order to denote the size of the sample. So the summation of our individual observation is 1 plus 2 plus 3 plus 4 and then plus 5, which will give us 15, and then our size of the sample is equal to 5. So therefore 1 plus 2 plus 3 plus 4 plus 5 divided by 5 will give us the value of the sample mean. So we have here 1 plus 2 plus 3 is 6 plus 4, 10 plus 5 is equal to 15 divided by 5. So our sample mean, so the point estimate is equal to 5, is equal to 3. So 15 divided by 5 is equal to 3. So this is the value of our sample mean. So this is a single value that tends to characterize or describe the population where this sample came from. So for example, if the total population is 1,000, so this value aims to characterize this population. So wherein this value is derived from the sample data. So wherein our data is just 5 observations. So aside from the mean, we can also solve for the median estimators. For example, we have 1, 1, 2, 3, 4, 5, 6, and then 7. So we have here 1, 2, 3, 4, 5, 6, 7, 8. Sabihin natin na we have 9 observation. Then, in order to solve for the median, to in order to know the median of this sample data, then we just need to arrange this in ascending or descending order and look for the middlemost value. So we're in here, the middlemost value is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is 4. So our median of our sample is equal to 4. So if we would like to solve for the mode, then the mode of this sample is equal to 1, because 1 is the most frequently appearing value in our data set. So median and mode is also a way of estimating the median of the parameter and the median of a population parameter and the mode of the population parameter. So this median is just the median of this sample, wherein our n is equal to 9. So this mode is the mode of this sample, where our sample size is equal to 9. So another point estimator is the sample variance, where we use this equation in order to solve for the sample variance. So S squared is our variance, sample variance, X is our individual observation, X bar is our sample mean, and N is our sample size. So we use this equation, we use this formula in order to find the value of our sample variance and in order to estimate the population variance. So let us have an example. So how do we solve for the variance, for the sample variance? So using the equation. So let's suppose that we have the values 1, 2, 3, 4, 5 as our data. Then to solve for the variance, we need to look for the mean, the sample mean. We need to look for the mean deviation. So by the way, this expression is called mean deviation. So how far is your individual observation from the mean of your data set? So that is mean deviation. And then this equation is called the square of mean deviation. So this is important. So the mean deviation and square of mean deviation is important when we are looking for the variance of a data set, because in the equation, sabi natin, diba, to solve for the equation, if to solve for the variance, we use the equation S squared is equal to the summation of the squared of mean deviation divided by the sample size minus 1. So this here, the value of this one is coming from this equation. So again, so suppose we have 5 samples with the values 1, 2, 3, 4, and then 5. So our sample size is equal to 5. To solve for the variance, the easier way is to create a table. So if we have here our individual observation, X is equal to 1, 2, 3, 4, and then 5. And then we need to solve for the mean. wherein the mean, kanina na-solve natin siya, which is equal to 3. And then, we need to get the mean deviation, x minus x bar. So, 1 minus 3 is negative 2. 2 minus 3 is negative 1. 3 minus 3 is 0. 4 minus 3 is 1. 5 minus 3 is 2. That is the mean deviation. After getting the mean deviation, we will get the square of the mean deviation. So, negative 2 squared is equal to 4. Negative 1 squared is equal to 1. 0 squared is equal to 0. 1 squared is equal to 1. And 2 squared is equal to 4. So, afterwards, to get the value, sabi natin kanina that s squared is equal to the summation of the mean squared of mean deviation. So, we need to get the sum of this mean deviation to get this value. So, 4 plus 1 is 5, plus 1 is 6, plus 4 is 10. So, the summation of the square of the mean deviation is equal to 10. So, let us now substitute our formula. So, we have here 10 divided by n minus 5. We have here n, which is 5 minus 1 will give us 4. So, 10 divided by 4 is equal to 2.5. So, the variance of this data set is 2.5. So, for example, we have again 1,000 total population. Then, coming from a sample where our sample size is 5, so this value is an estimate of the population variance. And we also have the sample standard deviation. So here for the point estimates, we're going to learn how to solve for the central measure of central tendency, which is the mean median mode. Kanina nakita na natin how to determine the mean, the median, and the mode, and the measure of variability, which is in this case we have the variance, sample variance, and sample standard deviation. So again, sample standard deviation is a point estimate of the population standard deviation, wherein to solve for the standard deviation, we use the following equation. Okay, so wala to dapat na ano. So wala yung 2. So dapat S lang to. So standard deviation, which is ang symbol niya is S, sample standard deviation is equal to the square root of the summation of the mean deviation squared divided by n minus 1. So as you can see, the value inside our radical is equal to the variance. So therefore, or the sample variance rather. So therefore, the sample standard deviation is equal to the square root of our sample variance. So if the sample variance is given, it is easier to solve for the sample standard deviation. If the sample variance is not given, then you can solve for the variance, then solve for the sample standard deviation by getting the square root of the variance. So for example, if we go back to our previous slide here. So our sample variance here is s squared is equal to 2.5. So therefore, for example, this is still our given 1, 2, 3, 4, 5, our individual observation where n is equal to 5. And then we know that the variance of this data set is equal to 2.5. Then to solve for the standard deviation, we just need to get the square root of the variance, and in this case, the square root of 2.5. So the square root of 2.5 is equal to 1.58. So this is now the standard deviation of our data set, and this standard deviation is the point estimate of the population standard deviation. So for practice problems, I would like you to solve for the point estimate. So find the point estimate of the population mean, of the population variance, and the population standard deviation for the following data set. So we only have here two problems. So scores in a long test in science, and problem 2 is lengths of seedlings in centimeter in a plant box. So the discussion of the answers to this problem will be on our face-to-face classes. So let's talk about the disadvantage of point estimation. So point estimate do not provide information about sample to sample variability. So therefore, questions like how precise is the sample mean as an estimate of the population mean, and how much can we expect a sample mean vary from the population mean. So take note that these questions talk about precision and this one talks about accuracy. So these questions cannot be answered by simply looking for the point estimate of a single sample. But of course, we can use the data coming from our sample to solve for the standard error using the sample standard deviation. However, the result of the point estimate coming from a single sample is not the best estimator of the population parameter. So if we use the values of a point estimate coming from a single sample, then we cannot confidently say that that is the best estimate of our population parameter. So for us to feel confident about our estimates as approximation of the true parameter value, so for us to feel confident that the value that we get, the point estimate that we get, can be used in order to represent the population parameter, in order to characterize the population, we take as many random samples as possible from the population of interest, and that from that many random samples we can create a sampling distribution. So wherein we learned sampling distribution in our previous lessons. So for example, so estimating the volume content of a coconut juice. So if you would like to estimate the volume content of a coconut juice produced by, for example, company X, so we can take a sample. So let's say sample 1. Let's suppose that our sample has a size of 10 coconut juice per sample. So the mean of our sample 1, which is 498, is not the best estimate of our population mean. So we cannot confidently say that the mean of the sample 1, which is 498, is the best estimate of our population mean. Because suppose we have 5,000 population, and then our sample size is just 10, then 498 cannot accurately describe or represent the population of 5,000. So what we can do is, instead of having one sample, we can get as many samples as possible. So for example, we can have 6 samples or more samples, solve for their sample mean, and then solve for the mean of the means, or the overall mean. So we get the mean of all of these sample mean. So the mean of the means provides us a better estimate of the population mean compared to the individual sample mean. And from the data, so since we were able to create a distribution of sample means, we can also solve for the variance of the distribution and the standard error of the sampling distribution. So these values of sample mean, these values of means, variance, and standard error is a better estimate of the population parameter. So the mean of means, with the symbol mu's of x bar, the standard deviation and the variance of our the standard deviation and the variance of our sampling distribution is still a point estimate, diba? It is, so if we have these examples, so the overall mean is still one value. This is still a point estimate, but using the distribution, the sampling distribution, we were able to solve for the accuracy given by our sample standard deviation and the precision of our data. So this is still a point estimate because the mean of means only has one value, the variance of our sampling distribution only has one value, the standard error of our sampling distribution only has one value. So therefore this is still a point estimate. So a point estimate will not always be equal to the population parameter. So if we have a point estimate of our mean, which is given by the mean of means, so we know that the population parameter sometimes can be higher than the population mean. So maybe the population parameter is greater than our population mean, or maybe the population parameter is less than our mean of means. So therefore, we can say that the true value of the population parameters lies within a certain interval of values, because the point estimate is not always equal to the population parameter. So since the point estimate is coming from a sample and not coming from entire population, then we know that the point estimate will not always be equal to the population parameter. Sometimes it can be equal to the population parameter, sometimes it can be lower than the value of the population parameter, sometimes it can be higher than the value of the population parameter. So therefore, we are not certain that the point estimate is the true value of our population parameter. So for example, we cannot be certain that the mean of means that we get from our distribution of mean is the true population mean. So again, from this information, we can say that the true value of the population parameters lies within a certain interval of values. So when we estimate population parameters using ranges of values, it is now called interval estimation. So in our next video, we are going to talk about how to perform interval estimate of parameters and the concepts that are related to interval estimate of parameters.